connecting point, our discussion club, discussion evening. Я очень рада приветствовать вас на нашей виртуальной площадке Русского дома в Брюсселе на заседании дискуссионного клуба «Точка соприкосновения», которым мы открываем нашу космическую программу. В этом году исполняется 60 лет со дня первого полета человека в космос. И Русский дом в Брюсселе приготовил большую программу мероприятий, акций, посвященных этому историческому событию, которое разделило историю человечества на до и после. И поскольку без этого события было бы невозможно ни телевидение в его современном виде, ни сотовая связь, ни в том числе проблематика, которую мы будем обсуждать сегодня, 5G, мы решили начать эту программу космическую с вот такой инженерной и очень технической, но в то же время очень философской и общечеловеческой темы, как новые системы 5G, новая система подачи информации и телекоммуникаций. Я приветствую всех на нашем вечере, на нашем дискуссионном клубе и приглашаю всех к следующим акциям юбилейной программы, посвященной 60-летию полета Юрия Гагарина. Прежде всего, мы ждем вас 2 апреля на встречу космонавтов 3 стран – России, Франции и Бельгии и открытие выставки фотографий с орбиты российского космонавта-исследователя Сергея Рязанского, которая произойдет тоже на нашей виртуальной площадке, повторяю, 2 апреля в 19 часов по среднеевропейскому времени. Ну и другие многочисленные акции, и кино, и интеллектуальные игры, и творческие встречи. И еще мы 12 апреля, в День космонавтики, будем открывать Гагаринский зал в крупнейшем тематическом музее-парке Европы, посвященном космосу, который называется ExoSpace Center здесь, в Бельгии. И это открытие будет тоже в прямом эфире. Другими словами говоря, приходите к нам на юбилейную программу, посвященную 60-летию полета человека в космос, первого полета человека в космос, полета Юрия Гагарина. А участникам сегодняшней встречи, которых представит моя коллега Лукьяна Суворова, модератор сегодняшнего клуба, я желаю вам удачи, интересной дискуссии и поехали.
Thank you so much, Lera, for your very nice presentation. Indeed, today we have a very maybe unusual and interesting conversation. We are going to speak about 5G, and I'm very happy to introduce you our speakers. We have Scott Marcus, Jr., who is a senior fellow of Bregel think tank, that is the leading macroeconomic think tank in Brussels. He's also as well independent consultant dealing with policy and regulatory issues related with electronic communications and media, digital services. And from Russian side, I'm delighted also to introduce you Dmitry Lakantsev, Associate Professor of the Practice Center for Computational and Data Intensive Science and Engineering at Skoltech faculty by our leading innovation center in Russia, Skolkovo. And I would like to give the floor to Mr. Lakantsev to make a presentation introduction. Please, the floor is yours.
Thank you very much. Okay, so share my screen. So is it okay? Yeah, okay. So let me start. Thank you very much for this floor and for this opportunity to share my opinion and my knowledge about the subject. Actually, I'm not going to be very deep into the technical points of the 5G itself, but I try to explain how it works more complex and how it works in the real life. And just to explain the situation, well, it's a short disclaimer that all photos what you will see on this presentation is real. It's not from some photo banks or fake. It is just absolutely real. So first picture is very clarifying the deal. So basically here you can see the electronic value chain for the European Union here, and it's kind of the pyramid, and on the bottom you can see the materials and tools and some electronic components, and on the top you can see the services. So basically starting from the bottom, like from the materials and tools, we go to the services, and this total value chain for the well, almost all IT technologies. And here is about the electronics. What we can understand from this picture, first of all, that Europe mostly concentrated on the providing services. That's, well, more or less understandable, and this services is more complicated and more let's say expensive part of this pyramid, and this is okay. So basically production in Europe, talking about the services, at 25%. After that we have to point our attention to the industrial equipment, aerospace, defense, security, and automotive industry. So it's more or less complicated, very complex things built it on the low level technologies. But again, Europe here producing about the 20%. That's very good. If we can see the embedded electronics, and these embedded electronics definitely inside all this industry, industrial equipment and aerospace and automotive and so on. And here we can see that we can understand that embedded electronics more or less more produced in Europe. It's about 22%, and standalone electronics no. So basically, what we can understand here, that Europe mostly concentrates on very complex and let's say most expensive part of this pyramid. That the problem is we can see that the percentage of the low layers, like other electronic components, semiconductors, and other things, is quite low here. It's about 9% or something like this. What does it mean? That means that if you will remove from this pyramid the lower part, you can't produce the highest parts. So basically, yes, more complex and more expensive parts is and more cost effective is market services and market production. But actually, it's cannot build without the semiconductors and basic parts of this pyramid. And we can see it easily on this lockdown situation. So basically, it's a problem with the production of the semiconductors, shortage to the supply of these semiconductors right now. And after that, we have definitely problem with all the industries that based on these semiconductors. That means that our world is very, let's say, global and very unsafe and very dependable on the lower layer technologies. So we can easily extrapolate this picture to the history of the one country. It's Russia, definitely. So yeah, we can see what we do with our telecom equipment industry. And the first, we waste 25 years from 90s, and from the time then the Soviet Union collapsed till the 2014. And first of all, we just lost a big part of this industry. It was a big migration of the professional workforce to the West and other countries out of the former Soviet Union countries. And right now we have lack of protection of the Russian market and lack of state support for the industry. And it was the blind faith in some foreign partners and the perception of the global market principles. So basically, all our previous politics was based on the open market, on the global market, on the global world, and it was easily so we can skip the production of basic technologies. We can just use them to produce the end values and to have more money just for the services. So problem is right now it's a new normality. So first of all, we have a lot of sanctions from the 2014, including technological sanctions, some other things. So basically that means that we have problems and sharp drop of the exchange rate. This exchange rate caused the very high prices for the foreign equipment for Russia. And it's totally changed all the business models and totally changed the cost effectiveness of all our models that was used before. So it's a lot of risks, and that caused that Russia starts to develop and deepen relationship with the Chinese partners. That's obviously because you always have to have some partner outside to work with. And this is the China right now. So since 2018, we have new hope, so-called new hope, and new work, new, let's say, roadmap. So I head of the Skoltech NT Center of Excellence in Skoltech, and this Center of Excellence mostly go to the 5G technologies, artificial intelligence, photonics, and 6G. So basically, it's mostly about the basic technologies. As I said before, this is the basic technology. This is the infrastructure for a lot of the other applications, for a lot of the other services that can be provided based on this basic infrastructure, like 5G, telecommunication, AI. It's a basic technologies for robotics, for unmanned platforms, and so on. Photonics is a bit more basic technology for the microelectronics and for the basic components for the other layers. So this is a strategy outlook. It's more or less common words about the national value chain. So basically, we more concentrate to the value chains inside Russia, state programs, demand supportive initiatives. So basically, that means that it's some protection of the market inside Russia, just to accelerate the companies that try to develop and produce equipment inside Russia. Is OpenRAN, and talking about the OpenRAN initiative, I will explain a bit later. It's a new foreign partners and new industries. So talking about the OpenRAN, this is the main initiative, international initiative right now that, in my opinion, most interested in telecommunication market. This is a project that led by big enterprises, that led by big mobile operators in the world, like Vodafone, like Orange, like Telefonica, and led by the silicon companies and the software companies, like Facebook software companies, Microsoft software, Intel silicon, Xilinx silicon. Okay, what does it mean? That means that the market of the telecom equipment, I mean the operator class telecom equipment, is right now very, let's say, oligopolic, and just the 5 companies in the world produce all the mobile network infrastructure. Is Huawei, the biggest one, Ericsson, Nokia, ZTE, and Samsung. So basically, from these 5 companies, 2 of them is the Chinese companies, 2 of them European, more or less, because Nokia more or less, let's say, in my opinion, right now, Nokia is an American company, so United States company, if we just lead the ownership of the company, and well, Samsung from South Korea. So this oligopoly caused the very deep vendor lock for the operators. They depend on these 5 companies totally. And that's why they support the new initiative, that initiative just for the open architectures and open interfaces for the equipment. That means that we can divide the vertical and very close solution from the big companies to the different pieces, and to make these pieces in different companies. It's something like the PC market. So basically you can buy the very vertical solution from Apple. So hardware, platform, software, all the design made by one company. And another approach is to buy the motherboard from one company, silicon, I mean the processor from another company, put the software from, for example, Microsoft, it's another company, and after that to assemble everything in one piece and to have the same PC. That means that it's absolutely different situation with the proposition on the market, the prices, and so on. So this new approach that we try to follow, and this approach will help us to be to not depend on the only 5 big companies in the world. So we have new partners. That's obvious, is Russia and China. I don't want to say that the China is very, let's say, very friendly partner for the Russia, but still it's the big partner, and we deep our relationship with the China. And I have to say that for the Skoltech, for our university, the biggest foreign partner is the Huawei. The biggest partner from the industrial side, Huawei, the high technological company that produce full stack for the technologies, Huawei. So basically, more or less, our big partner is the Huawei. So this is adopted version of the Chinese 14 5-year economic plan for till the end of the 2015, and you can easily see that it's about the 5G, about the 6G. And the interesting point is the early version, this plan did not mention 6G. So basically this plan is effectively changed. And the very crucial part of this plan is the 5G and 6G telecommunication technologies. That is the basic technology for the whole digital economy. So this is the working prototype of the 6G we already have in our laboratory, and this is the picture of the door to one of our laboratories. And this is the main directions that we already right now supporting is 5G, 6G, photonics, and AI, all with more or less with the Chinese partners. So we are definitely open to the scientific and technological partnership. That means that it's not like the China is the only our partner. We are absolutely open, but right now we try to diversify our activities and to work with a lot of different countries and people. So our new products, what we already doing right now, what we are doing in our laboratories, and we are going to do it further, is first of all, full range of OpenRAN solutions for 5G and 4G, low-cost niche category. That means that we are going to use it in Russian market, and for example, in the market of Africa, in the market of Latin America, and the former Soviet Union countries. We own all the OpenRAN soft by ourselves, so basically we are developing it by ourselves, and actually we have a lot of test beds inside in Russia. So basically we're more or less independent from the other partners, and right now we can develop and let's say produce our own equipment based on their own software. So talking about the progress, you can see the speed test on the left. It was on October 20 of the 2020 in our lab. So we just produced our base station, just show the quite low figures. And well, yes, but right now we have absolutely other picture. So it's a great progress, and we are still progressing. Okay, it's not so great as the Huawei can show right now, but still we work very well. And we have biggest Russian operator MTS as a partner, and we have big test zone on the territory of the Innovation Center Skolkovo. and testing our own equipment in this zone. Well, it's a lot of different testing services. I'm not going to be very focused on this, but I mean that we have all the facilities and the necessary equipment to produce our own products. And one more thing, what we are doing right now is protecting of the traffic in the network with the quantum technologies. So right now it's a small project that called Quantum Messenger. And we are demonstrating the video calling out of the 5G network based on our own software, I mean in laboratory, and Android smartphones with the security based on the symmetric encryption using the quantum key distribution protocol. So you can see the big boxes for the data centers connected to the fiber that generating the keys based on the quantum technologies, and these keys translated through the base station for 5G through base station to the mobile phones, and these mobile phones protect and they secure the traffic with the new generated keys with the quantum key distribution protocol. So this is more or less all about our activities, and I will be happy to listen your questions. So, well, our role in this telecom equipment supply chain is changing, and we are trying to play more roles right now than before. Okay, thank you very much.
Thank you so much, Mr. Lakontsev. Yes, it's very actually impressive. And after we would like also to discuss a bit more details about Skoltech and things that you mentioned about Russian development. And now I would like to give the floor to Mr. Scott Marcus, who will represent also European side and tell about the developments in this field. So please, the floor is yours.
Thank you very much. Let's see, I am not muted. Good. Good. So thank you very much for inviting me today, Russia House, and thank you to Professor Lakontsev for really interesting presentation. I didn't realize that you were so much into OpenRAN. It's a very promising direction. The work looks very promising. Good. Well, I'm actually going to be focusing on a related issue, which is basically how do we get to actually deploy all these things that Professor Lakontsev's institute wants to build? How do we get the 5G networks out there? And for that, there are a whole range of policy questions. Now, 5G is a little different from previous mobile generations. And for this, any of you who've looked under the Christmas tree know that it's not always the biggest packages that are the best. With 5G, it's often the small packages that merit attention. So that actually is one of the key areas that poses challenges as we look to getting the networks built out. Now, 5G is important for a lot of reasons. It's expected to enjoy rapid growth. It's expected, of course, to be used for mobile broadband and for voice, like every previous generation, or like the more recent previous generations of mobile. But it also can be used for other kinds of use cases. It can be used for automotive. It can be used for process control. It can support different use cases at once: high reliability, low latency, different properties. So it basically entails a different way of providing mobile services to the world. Growth is expected to be rapid. Here you see some estimates from Ericsson, and there 2015 is on the left, 2025 is on the right. That brown strip in the right is the growing number of mobile users that are predicted, which is, I think, not surprising. We see 4G, which is the green, declining a bit. The older generations definitely shrinking, 5G taking up the slack. But more important really are the changes, the new things that 5G can support. So here you see a graph of Ericsson's projection on the growth of Internet of Things. Not all of this is 5G. The dark purple on the top is the 5G parts. The very light purple at the bottom is older mobile networks, 2G and 3G. And the bits in the middle are newer technologies that, again, offer low power consumption and that are especially suited for Internet of Things. So you've got a growth where 5G plays a large role. Frequency plays a big role in all of this. You remember turning the knob on AM and FM radios. Frequency enables us to distinguish different services in different frequency bands. A lot of the 5G use is going to be in relatively low bands, 700 megahertz, 800 megahertz. The most important band for Europe is expected to be the so-called 3.5, 3.6 gigahertz band. Gigahertz is 1 billion cycles per second. But something new with 5G that wasn't practical in the past is the use of so-called millimeter waves, especially the 26 gigahertz band for Europe, a little higher in the US. Now, the lower bands have the advantage of longer propagation. The signal can go much further. However, there's a limited amount of spectrum in those bands. The gigahertz bands offer a lot of data carrying capability, but over very short distances. It will probably be a while before we see much use of those bands, but they're important. This is a figure from an old report from 2014 that tries to explain the trade-offs. And those trade-offs have a lot to do with the deployment challenges that we face. The curve coming down, that represents the distance over which the signal can be expected to propagate. This is again with older technology and without something called beamforming. So it's a bit old, but it makes the right point. So the signal goes much further. That means that you need far fewer base stations to cover a given number of square kilometers. On the other hand, because you need a lot of base stations, a lot of locations from which the signals are sent, that implies higher cost. Even though the base stations are individually smaller, there's a lot of them. The calculation done here compares the relative cost, and that's what those blue bars are. It's relative cost at 400 megahertz, which is not really used, at 700, 800, and up to the 3500 that's expected to be the main band for 5G. And you can see that the blue bar is much higher, the cost is much greater. But it still pays because you can get far more reuse, far more different signals in the same square kilometer, which means you can carry one heck of a lot more signal with those new base stations. It means that they're going to be used, though, in a rather different way than traditional mobile. What we're likely to see in rural areas is a great deal of use of the traditional frequencies, 700 megahertz, 800 megahertz, the ones that go a long distance with a small number of base stations, because there's not a lot of customers and you don't need a lot of capacity. The dense urban areas will see frequencies such as the 3.6, and also the most dense parts of center cities. That's where you're likely to see a lot of use of these new millimeter wave facilities. They have strengths, they have weaknesses. One of the weaknesses of those millimeter waves, the 26 gigahertz, they don't penetrate buildings very well at all. So this has a big impact on a lot of the uses. Now, the shift to denser networks implies building out a lot of base stations. And that poses challenges. It's not just cost. Think about the challenge of getting a building permit. It's a mess in Europe. I'm sure it's a mess in Russia as well. You have to go to local authorities. You have to go through permitting. You have to go through maybe historic preservation for the buildings, a lot of stuff. So how do we actually get that done? Well, in Europe, there has been some work done at the legislative level. There was a major new framework to regulate electronic communications that was enacted in 2018, just came into force a few months ago. Part of it tries to ensure that the permitting has to happen fairly quickly, but there's still headaches with building permits, with historic preservation, and also with public concerns about health effects from electromagnetic radiation. So the new laws try to deal with a bit of this. One of the most helpful provisions tries to exempt small cells from requirements for permitting. A small cell, especially the kind of cells that are used for these millimeter waves, they're more like a Wi-Fi router. It's a little box. It's not a big deal. They operate frequently at power levels less than 10 watts. That's also not a big deal. And so essentially, the provisions of the new regulation prevent individual countries in Europe, prevent the member states from imposing restrictive rules for these small base stations that really can't do much harm. It also references some standards. One of the most important is how high above the walkway, how high above the sidewalk can the base station be? Well, they set it for 2.2 meters. I mean, when you do this kind of analysis, you have to think, who are the tallest Europeans? It turns out they're the Dutch. So you want to make sure that we're not needlessly frying any Dutch heads. And that means putting the base stations at safe levels. The new code also addressed electromagnetic fields a bit. And there's also existing regulations that try to make it easier to use other infrastructures, electric, sewer, water, whatever, in order to provide rights of ways for all of the fixed lines that are needed to connect those base stations. So a lot has been done, a lot still needs to be done. Cybersecurity, there are certainly issues with 5G. Many of the issues, though, are issues that we've known in the previous mobile generations. They play a bigger role here, first, because the use of 5G is expected to be very widespread, but second, because some of the new uses are novel. If we use it in process automation, if we use it, for example, for controlling power plants, the risk to security from hackers could be enormous. There have been big concerns about securing these 5G networks. It's gotten a lot of attention. There's also the issue of global supply chains, especially in the event that there might be future conflicts or at least headbutting with some of our global trading partners. Here, the US-China conflict potentially plays a large role. A second aspect relative to security is that it interacts with privacy. A lot of the new issues that have come up in Europe really relate to privacy, not in the context of what the companies are doing, but rather in the context of government surveillance. So there we have real threats to transfer of personal data from Europe to the United States. I predict we'll have big problems from Europe to the UK, and of course with the rest of the world as well. So there are lots of things to worry about. Now, Huawei has been very much in the news, largely because of the US-China conflict. I think there's some things you have to take seriously. There's some things you can take a little less seriously. Huawei's source code actually has been with an independent group in the UK for years. They say there's some things where the security isn't as good as you would like, but they don't see systemic risk in the software. So some of the claims that the US has made are probably not so valid, but the geopolitical threat aspect probably does have to be thought about. I'm going to say a bit now about health concerns. This has, of course, been a big issue. It happens that I was one of the principal authors of a study for the European Commission where I wrote the health effects chapter, and we looked at this closely. There have been standards in Europe since 1999. There's a public standard called the ICNIRP. It comes from the International Commission on Non-Ionizing Radiation Protection. It protects against thermal effects. They really don't believe there's anything else yet. And you would have to say the evidence on that is not conclusive. I'll come back to that. This is a very nice analysis that was done by the Polish Ministry of Digital Affairs. What they're worried about is that different countries within Europe implement different standards. Most countries follow the European guideline, which is based on this ICNIRP standard, but many of the countries have more rigid standards, much more restrictive. Italy is an example. Right in Brussels is an example. It's different from the rest of Belgium. And it turns out many of the countries in Eastern Europe have standards that date back to the period before the Iron Curtain fell, when people simply weren't thinking about these issues as much, and therefore have restrictive standards that would make it very expensive and very difficult to deploy 5G. Poland has done good work on this. To their credit, they enacted a law not long ago. They managed to find a compromise with all of the interested parties, and they've eased the restrictions now. but there are many countries where this still is an issue. There's a big literature on these health effects, but no conclusive harms shown. There's still people that will debate this, and I'm sure you've heard this. In fact, we had incidents not long ago in Europe where people were burning down cell towers that they thought were 5G, probably weren't, because they feared radiation from the towers. So trying to achieve public confidence is a big issue. The health effects themselves, there are some things that still could stand to be looked at more, but most of the concerns I think you would have to say are overblown. Now, the research results, there's a lot of research, there's a huge amount of research done. Even the best research often leaves questions open. Probably the best animal study that was ever done concluded in the United States 2 years ago. And what it did find was that in male rats, the exposure to radiation, similar to cell phone radiation, but at much higher levels, could cause certain tumors. So this sounds bad. Oddly enough, they found no effects in female rats, no effects in mice, and a really bizarre result, the irradiated male rats, and you'll recall these are the ones that were more subject to tumors, they actually lived longer than the control group. A question was posed by a New York Times reporter, does that mean we should all get ourselves irradiated? And the head of research said, well, I think it's a little early to say that. It actually, there are reasons, there are explanations that have been given for this, but the point is the research often is not definitive, mostly because it's hard to prove that there's zero harm. There have been a lot of epidemiological studies done. If there was a lot of harm, it almost certainly would have already come out. Now, these transmitters are going to be much closer to people than the existing ones, but they also tend to operate at much lower power. So the actual risks tend to be lower. It's not simply you have 10 times as many cells, therefore you have 10 times as much radiation. That's absolutely not the case. So again, they have to be looked at differently. Also, the health effects from the newer forms of radiation are different. And also you have to consider beam forming, which is the fact that the beams can be steered. These are no longer omnidirectional antennae. This is from a very good report done in France a few years ago. What it basically says is almost all of the radiation from these high frequency waves is dissipated very close to the surface of the skin, often within fractions of a millimeter, certainly within a small number of millimeters, depending on which frequency. So there's much less concern about this causing damage to internal organs or to the brain. You just can't get there. If there's damage at all that could be caused, it would be to skin or the cornea. But again, no concrete harm shown. My point is the risks are very different and generally much less for the newer forms of radiation. In the work I did for the commission, my colleagues did some very nice simulations, so-called Monte Carlo methods, ray tracing methods. What they found was that basically, even in worst case, it was unlikely that the radiation would be even 1/100th of the currently permissible ICNIRP standard. So probably nothing to get excited about today. Our recommendations to the commission were to fill in some gaps in the standard, including this bit about how high above the walkway the base station should be. And we also recommended that the commission put in place a review process where relevant standards would get looked at not by the European Commission experts on telecoms, which is where this was historically sitting, but rather by the European Commission's independent expert panels driven by the parts of the Commission that deal with public health. They already had good committees to do this. Somehow they'd never put the two pieces together in quite this way. So this will be done, and I think it makes good sense. And with that, hopefully we'll have a little more clarity over time in what the real risks are. So there's a lot that needs to be done to get these services deployed, and there's a lot that can be done, and there's a lot of room for policymakers to try to do it. And with that, back to the moderator, and once again, thank you very much for having me, and thank you again to Professor Lekontsev for very good initial remarks.
Yeah, thank you so much, Mr. Marcus. And I would like to ask our first speaker, Dmitry. You've mentioned also about the Russian policy with neighbor countries. If you could tell a bit what is the position maybe of China in this region, and what is the position of Russia, and how the technologies are developing there? What is the situation? Is it a field of struggle or field of cooperation?
Well, frankly speaking, is always the field for the competitiveness. So basically, you always compete with the other countries. It's impossible to have some strategic partnership. I don't believe really in such kind of things. So, for example, inside the European Union, yes, it's possible. But if you have the absolutely separate countries, they always compete and they always try to build up their own technology. Talking about Russia, for example, and China, there are no any exchange between the countries in case of the technology. Chinese, they're easily to sell the equipment inside Russia. So basically more than a half of the, well, it's about the 40% of the equipment in the mobile networks in Russia, they are from Huawei. Actually, other parts is more or less half and half from Nokia and from the Ericsson. So basically, it's more or less diversification, but still the bigger part is Huawei. But it doesn't mean that Huawei are going to share the technology with Russia. From the other hand, one of the biggest research, not development, that's a very important part, but research department exactly in wireless technologies from Huawei is in Russia. So they have almost 400 people right now. And I mean, they're only engineers and researchers and R&D workers. And we interact with them very highly, but it's very deep, but it's more or less about the research for further research, for further networks, for future networks, for future technologies, or something like this. But all the development inside China, and they're very strict about this. And well, we have to develop this by ourselves. This new approach, I mean, this new project, OpenRAN, is a new international project, is very helpful for us in this case.
Mm-hmm. And what about the area of Commonwealth of Independent States? If you could also tell about this region, how they are developing, they are cooperating more in this field with Russia or with China?
Yeah, it's a good question, and actually we have very strong communication, very strong relationship with the Kazakhstan, and our main partners from the operators part is MTS in Russia and Kazakh Telecom in Kazakhstan. So basically, this is our main partner. I mean, Kazakhstan. Talking about the other countries, they are more or less have their own independent politics. Talking about Belarus, they right now is under some disturbances inside country, and they don't have time to speak about the technologies, but yeah, you're talking about the countries. The main partner is the Kazakhstan. Other countries, they are more or less work independently.
Okay, thank you very much. And Mr. Marcus, and what about UK and Brexit? Did it influence also somehow the policy of the European Union and maybe UK by itself?
Well, the markets continue to be pretty integrated. So in that sense, not particularly. The area that I'm especially keeping an eye on, though, is something that I mentioned very briefly in my remarks, which has to do with international data transfers for personal data. Many of your listeners will have heard of the GDPR, the General Data Protection Regulation, which seeks to protect personal data of Europeans. There was a very important court decision reached over the summer, a decision called Schrems II, where the European Union's High Court, the Court of Justice of the European Union, said that transfers of personal data to the United States were essentially immediately blocked, not because of what the companies were doing, but because of what the US government might be doing. Basically, the concern was that government surveillance was so extensive and the rights of surveilled individuals so hard to assert that transfers of personal data outside the EU to the United States had to be prevented unless the companies could somehow ensure that the data wouldn't be abused. Now, some of the companies will do that, like Apple, for example, will probably argue that their encryption is good enough and that they flat out refuse to give their keys to US government surveillance authorities. But in general, it's a huge problem for European businesses. It's a huge problem for American digital platforms. There's not a solution yet. There had been an agreement between the EU and the US. This is exactly what the court decision threw out. The issue with the UK is going to be very much the same because government surveillance in the UK is every bit as intrusive as that from the US. Currently, the European Union gave them an interim sort of a pass, but my prediction is it won't stand up to judicial review. The first time someone brings a court case, it will probably fall. And then the EU will have big problems, and that will really cause problems for integration of UK and European businesses. And of course, the UK has been a member of the European Union for decades. The companies are integrated. If there are issues with transferring data, they're going to be big issues. The original case was about Facebook. People say, well, it's an American platform, who cares? But I talked to other European companies like Airbus. A lot of their manufacturing is in the United States. They're also largely French, German, British. So if they have problems on this, it'll be big problems. That's actually where I expect the shoe to really rub. That's where I expect the problems to be.
Okay, thank you very much for your answer. And actually, we have one question from the audience that I would like to read, and then I will come back to my questions. So this is to both of you, the question from Jana Kozari. If 5G is eco-friendly?
I'm sorry, you broke up a little. Could you say that again?
If 5G is eco-friendly?
Oh, ecology.
Yeah.
Do you want to take that first, Professor Nikoncev?
Okay, so that depends from the point of the view. So basically, if we're talking about the damage of for the people, I mean the radiation and not ionizing radiation and so on. In my opinion, the report of Mr. Scott was absolutely exhaustive here. So it's absolutely no harm anyone. And I agree that in Russia, by the way, we have very strict regulations, much more strict than in Europe. And it's more or less the same as the Eastern Europe countries. Actually, it was the projection from the Soviet Union to the Poland, for example, or something like this. So we still have this regulation, but in my opinion, it's absolutely no damage from the radiation from the 5G cells, and it's no in physical point of view. From the point of view of physics and physical way, it's no any difference between the 4G or 3G or 2G networks. It's still just electromagnetic radiation that the people use like 100 years or even more. Talking about the other things about the ecology, we have first of all the energy footprint. So it's the energy consumption by the equipment and all this heating and so on. And one more aspect is about the producing the equipment itself. I mean, first of all is the batteries, is very eco-damaging technologies, is the producing equipment itself. And yes, well, it's damaged a bit ecology, but it's like any other electronic equipment. So from this point of view, is any difference? And talking about the energy footprint, this is, in my opinion, the only thing that can be optimized. And again, all these new microelectronic technologies and all the systems for optimization of the radiation or the power consumption of the base station, you have to understand the power consumption is a big cost for the operators, and they too try to decrease the level of the power footprint from the base station. So in my opinion, the 5G even maybe more eco-friendly technology than other electronic devices. For example, some data center that store a lot of data and process a lot of data much more eco-damaging than 5G equipment.
Yeah, if I may. So first, I agree with everything that Professor Lecontev just said. Taking it a little further on the power side, it seems to me that the power used for the sort of lower frequency, long distance kind of use of mobile, it's hard to see how that could be any worse than with the current generation of mobile technology. If anything, it will be better because they're building better things, better equipment. The characteristics for the smaller cells, especially for the millimeter wave, might look quite different and might actually look better. Again, the millimeter waves, these are really small things. They're like a Wi-Fi router. They're operating at power of 10 watts or less. And normally, because they're beamforming, they're pointing things right at the user. It will mean that there's power being used really mainly only for people that are actively using it and who are pretty close and therefore can be reached using relatively lower power than is typical today. So I haven't seen any analysis on this, but to me, if anything, I would expect the energy footprint to look a bit better than the current generation, at least for an equivalent amount of use. What we may see is a lot more usage, but that's a different issue. We're getting benefits from that if we do. So that is the first point. The other actually has to do more with sort of pollution in the sense of visual pollution of the environment, because again, there will be more base stations. I don't know if you've actually seen what one of these small cells look like. And there are also small cells used in 4G as well, by the way. But often they're placed either on the side of a building or else they're street furniture. There'll be a metal enclosure for a bus stop or a tram stop, and a base station will be a little thing sitting on top. And if they're done sensibly, they can actually look pretty nice. So I would tend to think that this kind of visual intrusion, if it's done well, doesn't have to be a problem either.
Mm-hmm. Yeah, thank you so much. And following actually this question, I also would like to address another one. How do you think, would it be possible to live without 5G right now? Maybe should we use what we have, or should we wait for something that is coming after, like 6G, for instance?
Well, the big issue about 5G, each generation brings more speed, each generation brings more capabilities. But as far as simply running data faster, I suppose that 5G isn't something that we would die if we didn't get. It seems to me that the bigger issues have to do with some of the novel applications. The number of Internet of Things devices that can be supported with the current generations is far, far less than what 5G can support. So really, it's not so much, I think, the question of whether the mobile generation would be the issue. It's what all the other applications are that we would be foregoing. Now, we don't have them today, so you can't say that all of society would collapse, but we would probably forego a lot of economic gains that we can otherwise achieve.
Mm-hmm. Thank you very much, Mr.
Well, I want to add that actually you have to think about the 5G and 6G and these new technologies as first of all about the basic infrastructure. So for the IT, all these mobile technologies, new mobile technologies, like the high-speed roads for the road system. It's like the planes for the traveling, and well, it's a good analogy is electricity. So basically, right now, electricity is one of the very basic infrastructure. So first of all, you build a house or some building. After that, in this building, you first have the electricity. After that, the water, and so on and so on. The point is that the 5G is something new that for the moment we don't have all the spectrum of the applications for the 5G that can be shown to the public. So it's like all the people ask me why we need so high speed, or why we need all this IoT. That's kind of very strange. Again, it's like an electricity. It's very difficult to explain to the people in the end of the 19th century why you need this electricity. So then Michael Faraday shows the first let's say usage of electricity, and the people always ask him, what do you think about this electricity, why we need this? So we have the candles, we have the ovens, we have coal, and we have all such kind of things. We can heat our buildings and so on. So why we need this electricity? And right now you can easily explain, oh, you have dishwashing machine, you have the PC, you have the mobile phone, you have the lights, you have everything that powered by electricity. And this is absolutely the same analogy with the 5G and 6G. In nearest future, this 5G and 6G connections will be in any device that have battery inside. This is my absolutely sure in this. And all the application that will use 5G and will use all of these opportunities that provide 5G, all these new technical things inside the 5G, they just will be in the future. We can't imagine for the moment, and can give you an example what exactly the applications will be, but they definitely will be, I just promise.
Yeah, thank you very much for the comments. And following this topic, I would also like to ask Mr. Lakontsev, actually, in my opinion, humble opinion, it seems that Moscow is very digital city. So there are many technologies. Wi-Fi is almost everywhere, bus stops, metro, so on. While in Europe, in my opinion, people use less Wi-Fi. Internet in general is more expensive. How do you think, why it's like this? Is it just different the speed of using technologies, or it's also the matter of policy?
Well, in my opinion, there's two aspects here. First is the very low barrier, very low level of entering new technologies in Russia. So actually all of Russian people are very open to the new technologies. And all this, well, I actually usually quite frustrated a bit in Europe or in United States sometimes about the technologies. I said, okay, I have it in Moscow like 5 years ago. Why you don't have this? And this is very strange. And well, it's I don't know. It's some kind of a mentality maybe. So the Russian people, they're open and they're easy to adopt to the new technologies, especially in IT. First, second, a lot of efforts put the government, in my opinion, because they do all this digital government, all these state services for the people, and these state services, they put a lot of efforts and a lot of money in this, and it's really work. I have to say that all this bureaucracy that was before, the same, and sometimes even more, but right now it's in a digital form. It's absolutely easy to work with. And the last thing is let's say price to quality issue. because talking about the price of the IT services and for example, mobile access in Russia is way cheaper than in Europe, for example. Yeah, so basically it's sometimes in 10 times sometimes. So basically it's very cheap internet access in Russia. And talking about the prices and the quality is very high quality. And that's why it's that penetrates so easily in Russia. And the last thing is the Moscow is a big city actually. It's about 12 million or something like this. So it's a megapolis, and of course any new technologies easily goes to the megapolis. And the second thing is about the Moscow. Moscow is very let's say rich, in my opinion, rich city. So have a lot of money for the infrastructure, and put a lot of efforts to make these digital things inside Moscow more and more. So basically, it really is. So I see every year we have new services, we have new technologies, and so on. So the pity and the sad thing about the 5G that we still have problems with the regulation in spectrum, and we still don't have enough spectrum allocated for the 5G networks. Otherwise, all the Moscow, I think it's even 1 year ago was on under the coverage of the 5G, definitely. Only the regulation stops the total coverage of 5G for the cities in Russia that more than 1 billion people.
Yeah.
So now we know the solution. I should move. I can get good digital services and cheap broadband, and I can help you folks with policy.
Yeah, that's an interesting idea. And Mr. Marcus, have you ever been to Russia?
Yes, let's see, twice. Once I took a few days of vacation in Moscow, and once I was invited to speak at an event jointly done by the Primakov Institute and let's see, a German institute was the other funder.
Yeah.
So.
Yeah, they're our partners as well. We also organize together some events. But I have to you maybe more moral question. I've heard from many European friends that they, in contrast, they prefer to use less digital technologies. They prefer not to use social media because it's not obvious how the personal data is used, and so on. How could you maybe comment this, or maybe it's just the wrong opinion?
Well, I think different people have different opinions. I mean, I personally have been a digital expert for many years. I was chief technology officer for a big US phone company before I moved to Europe. But I think, and this comes a bit back to what you were discussing a moment ago with Professor Lekontsev, I think particularly older people in Europe tend to be more traditional in their approaches and slower to take up technology. One widespread problem in Europe is that small and medium enterprise, small business, is very slow to take up digital technology, and it's been very hard to move that along. And a lot of Europe is in small businesses, so this really is a problem. There are genuine issues, of course, with digital platforms. This is yet another policy area where the European Union has been active. As you may know, there was a Digital Services Act that was put forward in December that tries to create some guidelines for the big digital platforms to ensure now not just privacy, but also sort of fair practices, a level playing field. A lot of work can be done there. Europe doesn't have the same kind of laissez-faire approach as the United States. It doesn't simply let businesses do what they want to do and ignore the problems. And I think somehow building more trust is important. But I think you've got a basic conservatism among a substantial fraction of the European population, and that's just the way it is.
Mm-hmm. And also here I have another question. You were mentioning in the presentation the cybersecurity. And I read some articles about US case that actually one of the argument was against 5G, also that 5G technologies can interfere with data of intelligence services. So what do you think about this? Can it really be a threat in this case for national security as intelligence service or not?
Well, I'm not exactly sure what you're saying there, but the biggest concern I'm aware of has been expressed by the United States, and the concern has been that equipment produced by the Chinese could be used for spying on the United States and its allies. I think that's where you were headed with the question. Yeah. Okay. So there, I think it's important to distinguish what the U.S. has claimed since maybe 2005. They've claimed that Huawei and some of the other Chinese companies were systematically stealing data. To the best of my knowledge, they have never produced a scrap of evidence. And according to press reports, even in classified briefings, they've been unable to provide a scrap of evidence. Now, I happen to be an expert witness against the US National Security Agency, the US NSA, in regard to then illegal wiretapping of huge numbers of Americans that was done during the George W. Bush years. So I studied this a little. And it seems to me, if they were currently doing it, the data doesn't do anyone any good if it's still sitting in the switch. The data has to be getting back to the intelligence analysts. There's several ways that could happen, but it's hard to believe, knowing the capabilities of US intelligence, it's hard to believe that the US wouldn't be able to make a very convincing case without needlessly exposing their sources and methods. So my assumption is that it's pretty unlikely that this is happening on a large scale today. And it tends also to be substantiated by the fact that British authorities have had the source code for years, and they also say they don't see systemic problems in the source code. That's a different question from saying, could there be a systemic risk if there was a blow-up? Suppose, for example, that tensions between, say, the People's Republic of China and Taiwan were to escalate. Is it possible at that point that that large quantities of Chinese equipment used in telecoms networks, which of course is already there for the existing networks, not just for 5G, would there be ways that it could be exploited? Quite possibly. I don't think anybody could rule that out.
Yeah, okay, thank you very much. And another more kind of moral question to both of you. Technologies are developing very fast right now. Actually, the amount of data is also increasing a lot. And sometimes it seems that human beings are kind of slower than technologies, and they always have to run, I don't know, to have new skills or even some health issues, capacity to be able to protect themselves, and also not only to use technologies, but to match these technologies. So is it like this? And what is going to be our actually future? We can foresee it a bit. What do you think?
Well, I think it's a very real issue. I think that almost all of us today are overloaded with too much information, and we face huge challenges in distinguishing what's false from what's true. Now, there was always false media information. If you look back at what used to be called yellow journalism, traditional print media were certainly also used for false information. But the speed with which it can be spread, and also the possibility to make convincing fakes, including fake pictures, fake images, is accelerating the risks enormously. Policymakers are in a catch-up game. I mentioned the Digital Services Act. They're trying to find ways to deal with some of these threats. Partly they're trying to put the burden back on the companies, you tell us what the risk areas are and you figure out how to mitigate them, which I think is more promising than than a top-down regulatory approach. But I think we face huge challenges, and I don't think it's an easy problem at all.
Okay, thank you very much. And Mr. Laconce, what do you think?
Well, we have some new term that sounds like the digital hygiene. So basically, you have to be very precise and have a lot of accuracy about the information you're reading, you see, and so on. And yes, it's a lot of data and a lot of a lot of room to let's say to fakes, to the freaks, and so on and so on. But well, actually, you always have some quite simple rules how to decrease dramatically all these fakes and so on and so on. Basically, we have the filters on your PC and on your smartphone. You can use your own common sense just to see the new information and try to critically understand it. And in my opinion, the technology doesn't add anything new for the human being nature. So basically, humans, they are humans, and this is just well, we right now have technologies to short the distance between people, to understand the people right now. It's much more open for the society, and you can see the social profiles and so on and so on. But in my opinion, again, this nature of the human being doesn't change. And anyway, I don't see the problems with the technologies. All the problems in modern life, we have the like epidemic situation. It's not the technologies. Well, planes and all these flights, international flights, add some risks here, but still, it's not a critical path. And the second thing is that we have problems with the political issues, with the ignorance, with some, I don't know, some things from inside the human being nature. It's not a problem of technology.
Okay, thank you very much. Actually, I was speaking not only about information as a sense of fake news, but also the amount of information that our brain should absorb, analyze, and work on, amount of stress that we have nowadays. But actually, you've answered the question. Thank you. And coming to an end, because we are already speaking 1 hour, almost 20 minutes. So I would like to ask you to make a kind of broadcast. What is the future? Okay, 5G, 6G, and what is actually going to be the big difference? Maybe there's going to be some other new technologies, as you mentioned, photonic development. So what kind of world we are going to live maybe in 5 years? Let's try to see there.
Well, in my opinion, it will not be a big difference in 5 years, but in 10 years, yes. So the critical, well, in 2024, 25, 26 will be the massive deployment of the 5G. So right now it's still not a massive. It's sometimes the testing zones, sometimes it's big cities like the megapolises and so on. And in 5 years, it will be the massive deployment of the 5G. And near to the 2030, it will be changes based on this new technology. What we can forecast, in my opinion, first of all, is the robotic platforms. A lot of robotic platforms that will be used in the industry, and the connected industry equipment that use the 5G connection will be. Second thing is unmanned platforms, and not only flying unmanned platforms, and unmanned transportation and unmanned cars. And I don't believe in unmanned cars on the open roads. in the cities. Still, it's yes, we see some well, quite impressive things from Tesla and so on, but still in the just open roads, I don't believe in absolutely unmanned cars. But in special transportation, yes, it all will be absolutely unmanned, and all other unmanned platform too. So basically, the main thing that can produce the 5G, that can accelerate 5G, is unmanned platforms and tele-sensing, managing something, and well, some unmanned technologies, yes. So this is the main points that we can see. A lot of people say about the game industry, about the augmented reality, virtual reality, but this is have no big sense for me, because actually usually all the applications, they drive by the economical cases. And when we talk about the unmanned robotic and so on, it's absolutely pure and clear economical models and economical things. And talking about the entertainment, like augmented reality and virtual reality, yes, it will be true. But as I said before, we can predict totally the application, because this application doesn't exist for the moment. And well, in 10 years, we definitely will say that how we lived before without this application, definitely. But what it will be, I don't know. But anyway, again, the 5G and let's say 6G, all this telecommunication infrastructure is totally like the electricity of the 19th century.
Yeah. Okay, thank you so much.
Yes.
And
Well,
Mr. Marcus?
Yes, I was going to say, so I think Professor Lekancev gave a wonderful answer in regard to how the technology is going to evolve. I'll maybe try to give a little different focus on what does that mean for how the society is going to evolve, how is the world of work going to evolve, and so on. And of course, we're going to see absolutely enormous changes. 5G is a piece of that, but it's one of many pieces. The fixed network also is changing. We're building fiber out to lots of homes. Certainly a part of this is that everybody will be connected with very capable fixed and mobile networks all the time. The good news is that we're always reachable. The bad news is we're always reachable. There's been an increasing interest in recent years in Europe and elsewhere, maybe that a right to disconnect is needed. I'm certainly one of many people, probably most people on the call, are doing their work from home these days. That's a profound change in the way the society works. Not every job is going to be done that way. My hairstylist is not going to be working, she has to be where her customer is. Construction workers, agricultural workers, fisheries, you'll see a different evolution there. But this notion of remote work was possible for decades, but much less of it was done than could have been done. Companies were resistant, managers were resistant, there was a worry about loss of control. They've been forced to do it, and suddenly they find they can do it. This is a profound societal transformation that would not have been possible if the technology weren't there. The way that we're conducting this meeting today would have seemed like science fiction 10 years ago. I mean, the technology was there, but it's just not the way it would have been done. So we're going to be seeing continuing profound societal transformations. The impact of artificial intelligence, machine learning, big data on the world of work is going to be profound. There were predictions a few years ago that a large fraction of all jobs in the United States would be at risk of being replaced in small numbers of decades. Nobody really believes that today. The conclusion is the tasks within the jobs will change, but mostly there will be as many jobs. The nature of almost every job will be transformed. And that's a big change. So we'll be living in a very different world in 1-2 decades, and we better get ready for it.
One more thing I want to add, actually, the market of the labor will change differently. So right now they have a lot of people from the third world countries that work in the rich countries and so on. And right now new technologies just give you ability to work distantly, and all this lockdown situation learned that almost everyone, if it needed, can work distantly. And that means that next step, you can use people from the other countries to work for you distantly, and afterwards you can see the absolutely global labor market for your company actually. And all of this providing you the really new technologies, and first of all telecommunication. And after that, then you can use the let's say cyber physics systems. Then you can manage some physical objects by the signals from the other part of the planet easily. For example, with the 5G, that will be some kind of the revolution. Mm-hmm.
Yeah, thank you so much. Actually, due to lockdown, we have more online events, and in this case, we are very happy to greet our honorable guests from different parts of the world. And now for the conclusion, I would like to give the floor to the director of Russian House, Madam Vera Bunina, please.
Но это не заключение, поскольку для того, чтобы делать заключение, нужно обладать теми научными и техническими компетенциями, которые есть у наших экспертов. Я хотела бы просто поблагодарить и господина Дмитрия Лаконцева, и господина Скотта Маркуса, потому что Русский дом в Брюсселе, Российский центр науки и культуры – это место, где мы стараемся, во-первых, представить новые технологии, новые наработки, обсудить важные научные современные проблемы для того, чтобы наша точка зрения российских экспертов и точка зрения европейских, международных, иностранных экспертов были услышаны с обеих сторон. И вот эта дискуссия научная и технологическая, которая сегодня у нас была, и которая была очень интересной даже для людей, не обладающих специальными знаниями. Я очень рада, что наверняка многие наши слушатели и другие слушатели, которые будут смотреть и интересоваться видеозаписью сегодняшнего вечера позже на нашем канале YouTube и на нашем сайте, они вынесли для себя много нового и наверняка стали больше 5G-friendly, потому что, конечно, это совершенно потрясающая новая технология, и это наше будущее. Однозначно мы в этом будем жить. Поэтому я просто хочу поблагодарить вас за это участие, за такой высокий уровень научной дискуссии и в то же время доступную для обычного слушателя, для обычного европейца и россиянина дискуссию, и пригласить вас еще раз, возможно, в другой момент для обсуждения какой-то другой, тоже интересной технологической проблемы. Я думаю, что это всем будет очень-очень интересно. Спасибо вам еще раз большое.
Thank you very much.
Thank you very much. It was a pleasure.
Thank you very much, and see you soon.
Okay. So we're done? Okay. So thank you very much, guys. It was like a very, very good actually event. So yeah, it was interesting actually. And sometimes I really learned new things.
Thank you. Likewise. I really enjoyed your presentation and your remarks very much, Professor Lacon. It was a real pleasure.
Thank you so much, really. And I would like to ask you authorization to publish your your PPT presentations on our website, if you agree or not.
Yes, please.
Just a question.
Yeah, no problem. Absolutely. Yeah.
No problem.
No problem.
Because we'll make
No
a little short text about it, about a publication, and we'll publish it on our website, and we'll send it to you as well. Maybe it's you'll agree to publish it as well, or some modifications, etc., etc. Because it will be a video on our YouTube channel. And publications on the website and social pages. Okay.
Great.
Okay.
So
About
we'll
how soon is the video likely to show up? When will the video be on? Do you know about how long do you take?
Yeah, we will send you. The email.
Good.
It will go fast. It will be tomorrow or after tomorrow.
Excellent. Okay.
Yeah.
Thank you very much. Okay, and Dmitry, if I may, so I hope we can keep in touch. This was a real pleasure.
Anyway, yeah, I'm absolutely open, so you have my contact, so be my guest.
I do.
Thank you very much.
Okay,
Thank you.
great, likewise.
Connecting
Okay,
point.
take care. A real pleasure. Thank you.
Yeah, bye-bye.
Thank you.
Bye now.
Ну, в общем, все. Что знал, рассказал.
Да. Но мы еще в эфире, поэтому да.
Да.
Все, да.
Окей,
Спасибо.
коллеги, да, большое спасибо. У меня тут довольно уже поздно в Москве, поэтому
Да,
с
конечно,
вашего
конечно.
позволения я уже
все пришлем. Да.
До свидания. До свидания.